So now we've got the geometry done. It's pretty simple. We can move on to shading and building the shading network. Before I go on though, I've recorded this twice now and things keep crashing on me. So every time I open the UV editor, which we'll talk about soon, Maya would not immediately, but eventually crash when I tried to do something. If you run into this problem, of course, I searched online to see what the problem was because it seemed like such a simple thing. But this is from Maya 2018, but it says Maya will crash when using the UV editor, and the solution is to switch from OpenGL rendering in the display to switching to DirectX 11. So I'm working on a Windows machine. So you can go to Preferences, go to Display, DirectX 11, and hopefully that will solve the problem. You have to restart Maya. Anyway, so we want to build a shader that looks like plastic, has a decal on the top, and has ridges along the side. So we saw at the very beginning that this is going to have ridges, but we didn't model them in. We're going to use a displacement map for that instead. We don't really have to do anything on the inside, so we'll just rely on the green shader for that. So really the only two places where we have to do something specific with the shading network or with textures is around the barrel on the outside here and on the top cap. And that's important to consider because we have to UV map this thing, which means to lay out this 3D shape onto a 2D plane so we can apply 2D textures to it. So UV mapping is always a difficult task when you first start to do it, and it remains a difficult task as you continue to do it, but part of the difficulty in the beginning is that it's conceptually kind of hard to wrap your head around. No pun intended, but if we go into the UV editor, hope it's not going to crash, we can see that when I was building this, I wasn't paying attention to UVs, because I knew I would clean them up later. But as I added new geometry, it would just add UVs into this space. So what is the UV space? So the 0 to 1 UV space is this one square here. And we try and keep all of our UVs, again, the 2D representation of all of the faces of our geometry laid out in this 2D plane. We try and put them all inside this one space, the 0 to 1 UV space. It's a much bigger space than that, but all of these are tiles of this, so it repeats. Now, there are some occasions where you can use more than one of these tiles for unique information, but most of the time you're going to stick to the 0 to 1 UV space. So, you can see that the original primitive, the cylinder, had some UVs laid out, so there was the top cap, here's the barrel. I deleted the bottom cap, so it's there. It's not there. So let's look at doing this. I'm just going to drag this here so we can see both at once. If I go to the UV menu set, I'll just tear this off. An easy way to do UVs is if you just click on automatic, and all it does is it looks at your object from 6 projection planes, and then it lays out what each of these planes sees essentially. So this top plane is seeing the faces up here. So you can see it's that face that I selected here. So that top face is laid out with that projection. And so if I just go into the channel box and click on auto project, I can see that again. So the thing with UVs and laying them out is that I can lay it out with automatic and then make changes to this. It doesn't matter. Sometimes doing automatic at the beginning is a good way just to avoid overlap. But I need to see this top face on its own and this side on its own. So I'm going to do some specific UV mapping for this. So let me just close that for a second. So I want to UV map around here and lay this barrel out flat. So I'm going to select these faces and just those faces. Except I selected the ones on the inside, of course. So instead I'll just click on one and then double click on its neighbor, and let's get that group. I kind of want to include these top ones too, so I'll select those as well. Not the bottom. Yeah, maybe this one too. So I'm selecting this ring of faces by selecting one and then double clicking on its neighbor, and we'll select the ring. And I'll go to UV and I'll do cylindrical map because that most closely approximates the shape I want. So it's kind of hard to see here, but it does sort of a half cylinder going around. And grab this red tab and just close that off. And if we look in the UV editor, now you can see the barrel here is this part in orange has been laid out. And it fills the entire UV space because this projector that we've created, this cylindrical projector, is sort of a deformed version of this square space. And so if you imagine taking what it can see and stretching it into this space, this is what we would get. But I want this to be kind of similarly shaped to the original. So I'm just going to grab this and maybe move it down here. And then I want to do the same with the top. So to select the top, I think I'll just drag across here, and I think I did it perfectly first go. Yep. And so instead of doing a cylindrical projection, and I think I may already have this one projected just right, but just in case, I'm going to go to, no, that might be off screen for you. So you can see it's selected here, and it looks like my automatic projection actually captured it pretty well. But I can also go to UV planar, and it will just do a single flat projection in the shape of the 0 to 1 UV space and capture these top, those faces I had selected. So I'm just going to scale this down a little bit. So these are the ones that I want to use to create, or where I'm going to place the ridges and then the decals. So I want these ones to occupy more space than the other part. So this part here is the inside, and I'm not going to put any textures on there. And so I can just move this off to the corner, and I can even shrink it down. Doesn't matter. Same with this. So I can go to UVs. If I double click, it selects the whole UV shell. Oh no, that's the one I want. Let me just move that out of the way so I can do the same thing with these ones. These are part of the inside threading. Just going to move those over. Now what is this thing? That's just the bottom, so I don't need that either. So everything should stay in the 0 to 1 UV space, because if I put this here, it's actually overlapping with this because this is tiling over here. So I'm just going to select these, scale them down. Oops. And just move them in here. Now these can overlap, I don't really care because I'm not putting texture on them. So I can just leave it like that. I'm just going to shrink this a little bit because I don't want it overlapping the edge of the 0 to 1 UV space. I don't think, or do I? Let's just leave it like that. If we run into problems, I will scale it down a bit. So these things that are using textures, especially painted textures, like this one, we're going to have a logo up here. You want them to occupy as much space as you can, proportional to other things in the scene that also get textures. Because let's say we make a texture of 1024 by 1024, then just this quarter is going to get, a quarter of those pixels. So the resolution will be limited to that. If you do a 4K texture, so 4096 by 4096, then this will be about a 1K texture up here. So depending on what you're doing, the amount of space they occupy can be important. Okay, so we've got that done. So I'm going to close that out now. Not going to worry too much about it. And let's put a new shader on here. So assign new material. I'm just right-clicking, go to Arnold Shader, AI Standard Surface. Just close these things. Save my scene. And let's just delete the history on this, freeze its transformations, go to the AI standard surface, and I'll call this Bottlecap material. And I'll give it a color. I'll give this one a different color than my other one. So there are some presets, and there's a preset for plastic here, but it uses subsurface scattering, and it looks good, but I'm just making something simpler. Do I have a light? Yeah. Do I have a big light? No. So I'm going to add a sky dome light here. Just turn its value down to 25%. So we can just look at the default material here, just the blue color added into the base color, so it looks fine. So under base, we have the color and the weight, and that's set to 0.8. So that means some of the incidental light is absorbed by the material. So you're only getting 80% of this color returned to you. So it's more accurately mimicking how real world objects work, I guess. If I turn this all the way up to 1, then you're getting a more realistic or more complete representation of this sort of lavender color that I have here. Diffuse roughness can also do this. You can see as I turn it up, it seems to get darker, but it's the idea of a micro texture on the surface that's diffusing and breaking up the light, so not as much is returning to the viewer or the camera. Metalness, if you need something to be metal, you just turn up metalness. Nobody knows what it does. Specular, right? So specular is how reflective it is. So right now, if I just turn this so we can see the area light being reflected in here, if I turn that off, then there are no reflections. It's matte. And you can have different colors here. So it doesn't make any sense, but you can do that. Roughness does what it sounds like. It makes it rougher. So if I turn this to 0, then we're getting more of a mirror-like reflection on here. So for plastic, probably want to roughen this up quite a bit. So even though it's pretty rough on that sharp edge here, we're still getting a nice, pretty bright highlight. That might be a little too high. Index of refraction also indicates how bright this will be, so you can turn this up higher. So this also influences, you can see how much brighter this is. This also influences transmissibility, so and how the light will refract through a transmissive surface. I'm just going to turn that back down, and then other things. So this is looking fine. Now we want to add a few things here. So the decal on the top, we want to add the ridges on the side, and we want to add a general bump. So just kind of a loose bump that makes it look a little less perfect. So these are different types of things in there. This is why this model is useful. So we've got two procedural textures. So one is the kind of loose bump, and one is the ridged texture here. They're both procedural, which means that they can be modified and that will update. It's based on procedural textures in Arnold or in Maya, and we'll take a look at these. But the real difference between them is that the generalized bump doesn't rely on the UV map to be placed over the surface. So if you don't want to UV map your model and you just want to add some general noise to the surface, you can do that as long as you use a 3D texture. So it's not a 2D texture that has to be laid out on the surface, but it's more like the whole space is being occupied by this texture, and wherever it intersects with the model, that's what you'll see. And that can be really useful, and a lot of the times you don't have to bother UV mapping. So let's do that one first. Okay, so I'm just going to stop this for now, and we'll save, of course, open the Hypershade, and let's take a look at this new shader that we're building here. So there's nothing to it yet, and so all we see here are two things. So the shader, and then this little blue nub on the end is the SG, the shading group. And this will become important later because the shading group brings together not only the shader, but it links to the objects that the shader is applied to, the lights that are pointing at that object, other textures like displacement maps that deform the object, and so on. So this, you don't really change much in here, but this is kind of like the quarterback that brings it all together, if I can use a clumsy sports analogy. So if we want to add a texture to this, then we need one. So we could go and search in here for one. If we go to 2D textures, bulge, checker, got a noise here. But we're going to use some Arnold textures. So there's texture, there's AI cell noise, which is good. AI noise, also good. Another way to find these in the Hypershade, if you just click tab in the workspace and start typing, it will narrow down the search field and show you the one that you want. So we're going to use AI noise, and I'm just going to place this into the color channel temporarily, just to show you how this works. So if I put this into the color channel and render this, now you can see the noise is in there. One good thing about Arnold is that if you just want to focus on whatever node you're adjusting, you can also click on that node, the noise node here, and then this circle with a dotted line around it. This is isolate select, so now you don't see the shading or anything else. You just see the effects of this node. And this is really handy for developing the look. So if I, it's running out of space here a little bit. So here, if we want a tighter noise, in the noise node here, we can increase the scale. So if I change this to 10 by 10 by 10, so we get a much tighter noise. If we want a looser noise, smaller number. So it's a broader, less frequent noise. Right, so something like this. So here you can see the coordinate space is set to object. You can also set it to pref. You can set it to UV if you do want to use the UVs, but when you do that, since we don't have, actually we do have our UVs sort of laid out now, but here we can see a seam. So this is where in the UV editor, the edges of this barrel come together, and so you can see the seam there. So we would rather use just one of the 3D. You can use world or object or pref. We'll just leave it at object. And we'll change the scale to somewhere, something like that. So, but we don't want this in the color channel, right? So let's stop this. Go back into Hypershade here. So we can break a link just by selecting it and deleting it. Now our object will just be black. So I'll just give it its color back. And then we want to use this as a bump map. So if we look at our object, and I'm going to go to display polygons, face normals, just so we can see what the face normals look like. So this is what tells Maya what the outer surface is and what angle that surface is at. So what a bump map does is it goes in and uses a 2D map of black and white values to change the angle of these normals. And just imagine this whole surface covered in them, changing the local normal to be perturbed a little bit. And it gives the impression of a bumpy surface, but it doesn't actually change the surface at all. So in order to connect this, we go into the shader, and under geometry we have a thing called bump mapping. So we could, if we just go to, if we middle mouse AI noise onto the words bump mapping, it will try and make a connection, and you can see it adds a new node, a bump 2D node, which takes this black and white value and puts it into the 2D space, into this thing called normal camera. So this is where things have to be connected, because it compares the vector of the camera normal, the direction that it's looking, with the vector on the surface of the geometry, the face normal. And so the thing we'd want to connect is just, you can either connect out alpha, can't see it here, it's maybe out transparency, or out color R, so just one of the channels of out color, to bump value. And that connects it up. You could connect this yourself, and I'll just show you how to do that too. If we just hit tab again and we start typing bump 2D, and we do the same thing, we can connect out color R to bump value, and then out normal to normal camera. So you can see now it looks like there's a direct connection from AI noise to the geometry tab here in the shader, but it actually goes through this bump 2D. Anyway, so the bump 2D, this value is always too high. So this is going to give you the impression of depth. So if we go to 0.1, now let's just take a little look. Turn off isolate select. Right, so now you can see the bump map here. So even though that's at 0.1, that's probably too high for what we want. We want it to be more subtle, even more than that probably. 0.02. And I don't know, it kind of depends if you want to make it look like very sort of granular plastic or something with just a more general bump. You can change the scale in the AI noise. So if I went to 5, right, so that looks pretty crummy. So I'm going to make it. So I just want to make it look like it's kind of imperfect. Yeah, that's a little bit more what I want. It's still a little too shiny, I think, too. So I'm going to turn up the specular roughness a little bit more. Okay. So that is how just to add a simple noise. Now we're going to work on using another procedural texture. And this is procedural because I can still go in and make changes and we'll see them play out in our shader. So it's not just painted one way. It can be changed over time and you can edit it. So we're going to use something called a ramp texture. And the ramp texture is probably the most useful, one of the most useful textures in Maya. It can just be a color node. It can be a ramp, different gradients, and we can use it for a lot of things. So we can just click on it here. It's under Maya 2D Textures Ramp, or we can search for it by going tab, start typing ramp, and you'll see there are a number of different ones here. The one we want is ramp texture because we want to use the UVs for this. So what I want to do with this ramp texture is just make a color change going from white to black, then click in here to make another color field to white again. And it's a V ramp. I'm not sure if that's what we want. We'll try it out. And we're going to connect this. I'm just going to put it in the color channel for now. So I'm going to connect the... Now this is just so we can see it. Out color to the base color. Right, so we can see our little black line there. I don't really see it on the sides at all. So I'm going to change this to a U ramp. Let's just see if that works better. Okay, yeah, so now it's going up and down this way. So what this means is a U ramp is that it's oriented in this direction. So that ramp is going along the U direction, which is like the x-axis. The V direction is the y-axis here. So just one line is not really what we want. What we want is to, let me just change the layout here. See if there's a good layout for this. No. I just want the hyper shade. Maya Classic. Okay, so let's just turn this into the render view. Can't do that. Okay, let's just put the hyper shade here. No, this is not going to work. Okay, let's just get in a bit closer here. Okay, I changed my layout a little bit here, so we've got our perspective view and our Arnold render view here. And so I want to repeat this pattern. So we've got our ramp node where I can make these settings here. I'm going to change the interpolation between the colors to bump. Now don't mistake this for bump map. It just means how it kind of, you can see how it looks like it's going into a groove down here from a high point at the white part. But in this place 2D texture node right beside it, this is how Maya understands how to lay this texture out over the surface. So we want to turn off wrap U and V, I think. We might want wrap U on. We'll have to see. The coverage is 1. And we want to repeat the value in U many times. So if we go to 2, and go up from there, you can see that we're getting more repeats of this as it goes around. Now it's being applied everywhere on the surface, and we'll fix that later. Right, so you can see that stripe pattern going everywhere, and we want to have these ridges on the side, so 50 isn't enough. Probably I can go to maybe 100. Maybe that's a good amount. I'm going to save my scene. So now, how do we control this black and white color from going on the top and on the inside? Because if we use this as a displacement map, so white will poke out and black will recede, we don't want that to happen everywhere else. So to solve that, we can use another ramp. And we can treat this like a mask. So we can, I'm going to take the out color of this one and put it in there. I'm going to take the out color of this one. So this is our original ramp. So let's call this ridge ramp. And this one we'll call mask ramp. So ridge ramp is in the U direction. Mask ramp, we want to be in the V direction. And we want ridge ramp to go into mask ramp. So essentially, if we look in here a little bit closer, as I change this, you can see that we're changing which part of the model is black and white, but moving it up and down in the V direction. So if we took the other ramp and had it occupy this space, then we can use it to limit which part of the UV map is covered by that stripe ramp. So this goes down to about 1, 2, 3, 4. So 40% of the way up here. So I can take this and go to 0.41, let's say. So that's the selected position. And that's where we're going to see this ramp. But how do we get this in here? Well, we just take select this color black, and we take ridge ramp, middle mouse drag it onto selected color. And then we take this color and make it black, and so we're masking it out. So you can kind of see what's happening up here. And you might be wondering, well, why is this part going black? But remember, this all depends on how we laid out these surfaces in the UV editor. So all this stuff that's inside the bottle cap, these are the spiral ridges, they're actually up higher here in the UV space. So that's why when this mask is blocking the top, but it's also blocking the stuff on the inside. Not quite though, you can still see a little bit of the stripe showing up here. But I can get rid of them by covering up more of that mask. And I might want this to just go down a little farther so it's not such a sharp edge here. And this fall off, maybe instead of linear, you can do exponential down. That's just the bias to go down a little bit. So maybe something like that. If we look at the bottom though, it goes right to the edge. So we could put another color in here and add black. And so now we're restricting our striped map to this area. But we have a gradual fall off. So this white one is the striped ramp, or ridged ramp as I called it. But it's slowly fading down to the black. So we could put another color in here and also attach the same ramp there. And so we have control over both sides. And just everywhere in between these two, it's just the ridged ramp. Let's try and match that a little bit more. Actually, I'm just going to make this smooth instead so it's equal on both sides. So that looks pretty good. So let's just stop this render and we'll save this. Okay, so we've made a map that uses procedural textures, because you can see I can keep changing them as I go along, to make this sort of pattern that we want. But now it's just in the color channel. How do we make it a displacement map? Well, the first thing we should do is actually check to see if it works as a bump map, because a bump map is always much cheaper to render than a displacement map. So let's just disconnect our old noise. If we wanted to have both, there are ways to do that, but let's not worry about that right now. And let's hook up our outcolor R to the bump value here. And let's turn on rendering again. Oh, let's change its color. Let's break this connection, change its color back to this, and render this. So you can see it is working, and from far away that might be good enough, and we can go to bump 2D and change it to if we go to 1, you know, it's not fantastic, and in fact it looks like it's going opposite the direction we want, so it's kind of hard to tell, but it's doing what it can here. But that's not bad. If you had this, if this was on the side of a microscope, if it was a dial or something, that might be good enough. So if you can get away with a bump, it'll be easier because it renders much faster. But if you have to get up close and personal to it, then a bump isn't always going to be that good. You can see it's really only approximating that shape. So how do you set up a displacement map, and what is a displacement map? So as opposed to a bump, a displacement map will actually deform the geometry. So it will displace the vertices to make the shape that we see in the shader, or in the texture. Let me just hook this back up again. But hooking this up is a little trickier. So For a displacement map, you don't actually hook anything up directly to the shader. Instead, you have to hook it up to the shading group, because this is something that doesn't just change the surface qualities, it actually changes the geometry. And the shading group is our avenue to the geometry. So we need an intervening node here. And this is where it gets a little confusing. Just click tab and start typing displacement. And we see one called a displacement shader. And it's its own shader. It's not just a node. It has its own shading group and everything. But to use this, we can happily just delete that shading group. And we just need this thing called the displacement shader. And so what are we going to hook up? We're going to hook up the outcolor R of the final ramp here into displacement. And then we're going to link displacement to the displacement shader attribute in the shading group of our material. Now this is a good time to save because this can become crashy. So let's render this. Okay, it looks fantastic, obviously. My bump map is way too high. Remember that was way down to 0.2. So let's go back. But you can see the displacement isn't really doing what we want. The reason for this is because we haven't given it enough polygons to work with. So displacement needs to actually move vertices around. So it needs more resolution in the geometry for it to work properly. And to do that, we go into the object itself, into its shape node. Let's give this a name. Demo cap. So we go into the shape node of demo cap, and under Arnold here, scroll down, we've got subdivisions. So this is a way to add subdivisions only at render time. So we can change type from none to cat Clark and turn up the iteration. So let's just try 3 for now. And you can see the difference here when I render again. Right, so now it's got more resolution to more closely match our texture. Now it's obviously pushing this out too far. So in the same shape node of the demo cap, under subdivision, we see displacement attributes. And we can turn down the height here. Now sometimes it doesn't show up immediately when you make a change when you're dealing with the displacement map, and you might have to go to render, update full scene, but it did work for me. But the good thing about this is because it's a procedural texture, I can still go back in here and say I want this to go up a little farther on the top, and you can see it's updating my shader. That looks better to me. I do want it to go a little farther, so I'm going to go down to the bottom. So you can also see, even though this renders pretty quickly, it's just such a simple model, but it does take longer than the bump map, but the results are better because it's actually changing the shape. And if we look at this from the top down, look in the alpha channel, if we turn off our background light, we can see it's actually changing the shape of the object. So just a couple other things to look at here. So in the shape node of our object, we can change the height. There's a thing called bounds padding. It's usually a good idea is to send this to a high value. And the reason for this is if your height exceeds your bounds padding, you'll get clipping and it'll look like it will end in sort of a square shape or something, or it will just end abruptly. In the displacement node, you can also change the scale here, and this is like an overall volume. So if you just want to turn everything down, you can turn it to 0.5 and it will update to just reduce the effects of this. There are different places you can adjust this. So if we look at our shader now, we want to map it out. We then have to select our shading group and click the input-output buttons. And so things look complicated, but they're not that complicated really. We've got our ridge ramp that's just repeated many times with this. We've Got our mask ramp that's just cutting off where we see it. It's going into a displacement shader, which attaches to the shading group, which is always attached to the material. And then we've got this little noise piped in through a bump. So we'll come back in the next video and take a look at how to add the decal onto the top.